This is the homework for 217, 219, 220, and 221. For 217, we need to simplify each algebraic expression. And if not possible to simplify the expression, explain why not. So I'm going to use algebra tiles to help simplify this expression. So we have 3y, so there's 3y, plus 2y, plus y squared, plus 5, plus y. So we're going to combine like terms. When you're using algebra tiles, same size, same shape. So we can combine these purple tiles, the y's, together. And you see in the expression, I circled them, 3y plus 2y plus y. So 3 plus 2 is 5 plus 1 is 6. Then we have 1y squared. So that's there's no other terms that we can combine that with. And then we have 5 units, 1, 2, 3, 4, 5. No other units to combine that with. So we end up getting y squared plus 6y plus 5. For 217b, you can see that each of these terms have no other terms to combine with. Here's a y square. There are no other y squares. There's an x squared, but there are no other x squares. Here's xy, no other xy's. So if there are no other terms to combine, then you're done because there are no like terms. For 217b, we have 3xy. There are no other xy's. You have an x. There's one additional x. So we can combine these two terms. 5x plus x equals 6x. Here's 2, a unit, so 2 units plus 4 units equals 6 units. And then we have a y. There are no other y's, so it's 3y. Now I'm going to order them in alphabetical order from the greatest exponent to the least. So alphabetical order, 6x, and then we have an xy, then the y's, then the units. For 217d, 4m, here's another m, so 4m plus m is 5m. Here we have 2mn. There are no other mn terms, so 2mn. And then we have m squared, and 3m squared adds up to 4m squared. For 219, we're going to evaluate the expression for the given values. And the word evaluate means to replace a variable with a number and to calculate the result. So we're going to replace the variable d with -1, because if d equals -1, so we're going to replace d with -1. So now we have, here was d, now we replace it with -1, and I put it in parentheses, and I always get into the habit, regardless of the expression or equation, I always put the variable in parentheses when I evaluate. This case is, it's in multiplication, so -4 multiplied by d, so -4 multiplied by -1. A negative multiplied by negative is a positive, so we get +4 plus 3 equals 7. For b, we have two variables, k and m. So k equals 4 and m equals -10. So here I'm going to put m in parentheses, and it's negative 10. So we have, and k equals 4. So 4 minus a negative 10. Well, this is minus a negative, so you can distribute this. You could say, what is the opposite of negative 10? Or when you have parentheses, you distribute it. A negative is a positive. So opposite of negative 10 is positive 10. 4 plus 10 equals 14. In 219C, we have t divided by w. So if t equals 6 and w equals negative 3, we have 6 divided by negative 3. The positive divided by a negative will be a negative. Anytime you multiply or divide numbers and they have opposite signs, it will always be a negative. So 6 divided by negative 3 is negative 2. For 219D, x squared plus y squared, if x equals 7, so we're going to insert 7 for x, and y equals 5, so instead of y, we're going to put the value of 5 there. Now we have 7 squared, which equals 49. Remember, when you square a number, that's 7 multiplied by 7, which equals 49. 5 squared is 5 multiplied by 5, which is 25. 49 plus 25 equals 74. In problem 220, a typical small bag of colored candies has about 135 candies in it, 27 of which are blue. So here's our small bag. Our small bag has 27 candies that are blue out of 135. At this rate, how many blue candies would you expect in a pile of 1,000 colored candies? So a total of 1,000. So this is our unknown variable. We don't know how many blue candies out of a bag that has 1,000 candies. So I set it up as a proportional relationship. And one way to solve proportional relationships is by cross-multiplying. So we have 27 multiplied by 1,000 and 135 multiplied by x. So we have 135x equals 27,000. Now we're going to solve for the variable x, find out how many blue candies there are. And this is multiplication. Inverse property of multiplication is division. So we divide both sides by 135. This creates a giant 1. 1 multiplied by x equals x. 27,000 divided by 135 is 200. So there would be 200 blue candies in a pile of 1,000 colored candies. In problem 221A, you need to name the coordinates of points A, B, C, and D in the form of x, comma, y. So that's an ordered pair. So A is at negative, remember, always start at the origin, -1, -2, -3, -4. On the x, +1, +2, +3 on the y. For B, +1, 2 on the x, +1 on the y, so 2, 1. C is -1, -2 on the x, and you're not going anywhere on the y-axis, so you stay at 0, so -2, 0. D is -3 on the x, -3 on the y. For 221b, we need to plot the point E at 5, 2, so that's 5 on the x, 1, 2, 3, 4, 5, and 2 on the y, 1, 2. Point F is at -3, on the x, 1, 2, 3, and negative 1 on the y. Point G is 0 on the x, so you're not going anywhere on the x-axis, but you are going negative 4 on the y. 1, 2, 3, 4, so that's 0, comma, negative 4. And point H is 2 on the x, negative 3 on the y.